Okay, now in this tutorial, what I'm going to do is I want to show you how the very basics of how a computer program works, how programming works, and then I'm going to show you slightly more detail how Java works. Okay, so here's the situation. Here we have a computer, and here's you, the developer. The computer does things for us. It does all kinds of things. Just think of how many things that computers do for us today. In order for a computer to do things for us, we need to tell the computer exactly what to do. The problem with that is that we communicate in an alphanumeric manner. We communicate, A to Z, 0 to 9. But the problem is a computer can't understand that. A computer, now you may say, well, I can write an email, I can type out instructions for. No. The computer can't understand any of that. Computer can only, at the lowest level, the computer can only understand two things: 0 and 1. That's it, on and off. We don't communicate very well. Can you imagine if our communication was limited to no letters, no numbers, except for 0 and 1? We don't communicate well like that. So the problem is, how do we tell the computer, how do we give the computer instructions when we can't communicate with it? Well, here's what we need to do. We need a computer language. The computer language, like the one you've been using, allows you to write instructions in an alphanumeric manner. It allows you to, it's not plain English, obviously, but it's pretty close to it. Alright? We see statements like print, echo, for, if, else, and whatnot. But the problem is when we write a computer language, when we choose a language to write instructions that the computer can follow, the problem is that the computer still can't understand what we're writing, because the computer doesn't understand anything except for, at the lowest level, 0 or 1. So what we need is a compiler. It's a software program that takes our computer language, takes the instructions that we've written in an alphanumeric form using a computer language, compiles it, okay, and what comes after the compiler is a program, alright, and that program is basically converted to a form that the computer can understand, but we cannot understand this program. We wrote it indirectly, but the compiler converts our instructions into a computer program that the computer can understand. Now we install it in the computer, we make the computer run it. The computer then executes the instructions that we have given to it. Alright? So that's how basically all computer programs work, then in a nutshell. Okay. So where we're going to go for here is we want to talk about how Java works. Alright? So same kind of an idea. Here we have a bunch of computers. We have a Mac, we have a Linux computer, we have a Windows computer. Here we have the developer, you, the computer language, Java, and the compiler. So again, we write a computer program in an alphanumeric form. We compile it, okay, and when we finish compiling, we get a computer program. All right. So same step as before, but where Java differs from normal programming languages is this. Now, if I try to make a Mac run this Java program, okay, it won't run. Okay, same thing. If I try to make a Linux run this Java program, it won't run. Same thing with Windows. It won't run. We're missing something. Now, in the case of Java, in order for these computers to run this Java program, we need to install the Java runtime environment. So now for the Mac, I'm going to get on my Mac, I'm going to go download the JRE, and I'm going to install it. There, it's installed. Okay. In the Linux computer, I'm going to log on to it, I'm going to download JRE, and I'm going to install it. Now on the Windows computer, same thing. I'm going to download JRE. I'm going to install it. You might want to notice that I have 3 JREs here, but they're not exactly the same. I color code them. They're similar in that they're similar colors, but the colors are different. The GRE for the Mac is only for the Mac. The GRE you download for the Linux is only for Linux. The GRE you download for Windows is only for Windows. Alright? So once GRE is installed in the computer, now what I can do is, if with my computer program, okay, the computer, I compiled it, okay, I wrote the program, I wrote instructions for the computer to follow, I compiled it, and I get something at the end, I believe it's called bytecode, it's a Java term. Now what I can do is I can make the Mac run it, okay, by running the program through JRE and then on the Mac. Now the same program, the exact same program, what I can do is I can run it on Linux, okay, through the Linux JRE and give instructions to the Linux computer on what to do. And the same computer program, I could run it on a Windows computer, alright, and yeah, I could run it through the GRE that I installed for Windows and run this on a Windows computer. Okay, I could do the same for Solaris, and I could do the same for any other platform that GRE supports. Okay, now the significance here is what that means is that you, the developer, you write one computer program, one set of instructions, you compile it once, and you have one program. And that one program works on multiple platforms. Extremely cool. Alright? Instead of you, the developer, having to write one version of the program for Mac. Alright, and let me just duplicate layer here. Alright. And then having to write a second version of the program. So instead of having to write one version, for the Mac, okay, instead of having to write a second version for Linux, instead of having to write a third version for Windows, we don't have to do that. Alright, we have to, well, okay, it's not really that simple, but theoretically we only have to write one version for the Mac, one version for the Linux, and one version for the Windows. So how exactly do we compensate for the differences in the Mac operating system, for the Linux operating system, and for the Windows operating system? Is we let GRE handle that. Okay, this plugin, because it's different for each one, this is what handles the differences in each one in the operating system. That allows us to write one program to work for all three of these instances. Okay. So this is in a really small nutshell. This is how Java works in theory. In theory, it just saves you from a ton of work if you don't have to write like three separate programs in a computer language for three separate operating systems. All right. Okay, while I'm here, I may as well mention that there are some disadvantages. The disadvantages are, of course, if you don't have GRE installed on the computer, well, your computer program is not going to run. All right. Or, for example, if you have the wrong GRE installed, the wrong version of GRE, an outdated version of Java runtime environment, the program may not run. Okay. That being said, there are plenty of Java programs out there that one called OpenOffice is one of them. Is you don't need to have Java on your computer in order to run it. What happens with a program such as that is you have the computer program and GRE bundled into one group, and you can install it without having GRE installed. But anyways, that's kind of beyond our scope. That's about it.